Hey everyone, welcome back. You made it. This is the last chapter for managerial accounting. Maybe you continue on with other accounting courses, maybe you don't, but I'm glad you stuck with me all this way. All right, so the good news about this chapter is that I kind of cherry pick, meaning that I only pick the things that I felt were the most important for you to know, and that's all we're covering, and that is all you're tested on, and that is all your homework is on, and so on, okay? So I'm just picking some of the items, so if you're reading the chapter, don't read more than you need to, unless you want to, of course, by all means, read. But if, whatever we cover in here is the most of what we're going to be talking about. Okay, so I couldn't leave you off without a conversation on lean manufacturing, and we did talk about this a little bit in an earlier chapter, but really very minimally. Okay, so now we're going to talk about lean manufacturing in much greater detail. I think it was chapter 3. Okay, so lean manufacturing. It can be called a couple of different things. You're going to hear lean manufacturing, you can hear just-in-time manufacturing. I want to say it's called Kaizen, which is an Asian term. I don't remember. Let me see if I have that up. It is a Japanese term. There you go. And it was an Asian term. And the idea is that with lean manufacturing, when you think of the word lean, don't think like lean. Think lean like thin, slim, streamlined, all right? Whereas if you want to do the alternative of that, like fat manufacturing, meaning lots of waste and lost time and things like that, okay? So lean means keeping it as smooth and as streamlined and as less filled with, I don't even want to say clutter, less filled with inefficiencies and waste and those things as you cut and rework and things like that as possible. And we're going to get into some actual hard examples in a minute. But it's producing products or services. Ooh, I forgot to turn off my thing. Ooh, too far. Hang on. Let me get rid of those paragraph marks. I have a habit of doing that. Okay. Now I'm showing you too much screen. Producing products or services with high quality, low cost, fast response, and immediate availability. Okay, it's also referred to as just-in-time. Now, the idea with lean manufacturing is what we've been talking about. What our normal manufacturing is going to be called is something called traditional manufacturing. Lean manufacturing is something that a company undertakes, and the idea is, like I said, reduce inefficiencies, keep it as clean as possible, make the products come out as quickly as possible. All right, so let me get into the concepts in a second. Now, the first thing I want to show you is that I grabbed this little chart here from your book. And why? Because it's a good summary of everything, okay? So I left that in your notes, and you can take a look at these. I'm going to go through a whole bunch of them. All right, but I'm going to hit right now the lean manufacturing main points. The main points is inventory is deemed wasteful and unnecessary. That's bizarre, right? You think to yourself, assets. Assets are good. Yes and no. Think about inventory. You have to maintain inventory. You have to make sure it's safe. You have to make sure that it's in a temperature controlled environment, depending on what it is. You have to make sure that it's not going to get stolen or that it's not going to become obsolete or go bad sitting on your shelves, right? So there's a lot of concerns about inventory, and you don't want to have a whole bunch of inventory sitting on your shelves collecting dust. It's just a loss for you. Okay, so one of the main manufacturing points for lean manufacturing is to reduce inventory. All right, basically you're only making the items that you plan on selling. All right, so let's hold that thought for a second. Another part of it is lead time. All right, lead time, also called throughput time, measures the time between when a product starts and when it's completed. So it's almost like the time from the time a customer picks up the phone and says, "Hi, I want 100 pencils." From the time that customer hangs up the phone and we say go on that 100 pencils, how long did it take us to then make those 100 pencils and get them out the door? That's the lead time, all right? Now, we want that time to be as short as possible. We want it to be as efficient as possible. And really, we don't want to even start manufacturing those pencils until the order is made. And that's the idea with lean manufacturing. You're not making things to sit on the shelves. You're making things to customers' orders. So you're not just making things and hoping they sell later. You've already made the sale. So it's as if, everything is customized. Okay, now lead time has a couple of different things to it. Value-added lead time and non-value-added lead time. All right, remember, lead time is the time from the time it starts and they start the order, the process going, to the time it makes it out the door to your customer. Now, broken into there is going to be something called value-added lead time and non-value-added lead time. Value-added lead time is when you're actually working on the product, okay? It's actually like in manufacturing, being made, somebody's handling it, doing whatever it is they do to it. That's value-added time, right? When you're actually making the product. But unfortunately, there's a lot of non-value-added time, all right? Sometimes the product is just waiting in the process, just by the way you have the process set up. Okay, so let's say it takes 3 processes to make a pencil. I don't know, I'm making this up. 3 processes to make a pencil. Now, in theory, you could be working on the one pencil in one place, and then you're done with it in the first process. And then what do you do with it? It probably sits until somebody can pick it up and take it to process number 2. That kind of thing is called move time between the different processes. And that's wasted time. It's unnecessary time. All right, there's a couple of other things that are unnecessary. I think I might be getting ahead of myself. I'm getting ahead of myself a little bit. All right, so hold off on that. One of the things we look at is we look at the value-added ratio. And the value-added ratio is how much of the lead time, the beginning to end time, is value-added, meaning how much of that time are we actually working on the product. So let's just say it takes us, 10 minutes to make the product, but it takes us like 12 hours to get it out the door. That would be concerning, right? It'd be 10 minutes over, 10 times 60? 600 minutes would be your total lead time. So you get the idea here. We're going to be looking at numbers with this in a minute, and I'll show you an example there. One of the things, okay, so moving on. One of the things that lean manufacturing wants you to do is to reduce things like move time, right? That's what I just mentioned. And reducing setup time. Reducing setup time. Let's say that I have my machines, and my machines can make small pencils, medium pencils, or large pencils, all right? To change my machine over, let's say it's set to make small pencils, right? And I just made a whole bunch of small pencils. But now I got an order to make medium-sized pencils. Well, it's going to take some time to then, recalibrate the machine, update it, change the setup to making medium pencils. Well, just in time, or lean manufacturing says that's wasted time, that's setup time. So what they would suggest to do instead is to have multiple machines. One machine that is only making small, one machine that is only making medium, and one machine that is only making large. And the reason for that then is you don't have to spend any time recalibrating machines. They're ready to go based on whatever the customer's order is. Okay, so that's setup time. That's wasted time or non-value added time. Batch size. This is the only one that really requires any true calculation. All right. Let's say that I've got a batch size of, I think I have 12 pencils. 2, 4, 6, 8, 10, yeah. Let's say I've got 12 pencils. Trust me, I promise you there's 12. All right, I've got 12 pencils here, and that's my batch size, meaning that every time I make pencils, I make them in batches of 12. 12, 12, 12, and they make their way through the manufacturing process. All right, so now let's just take one pencil out for a second. Let's say I'm making this pencil, right? I've got 11 in my hand, and I've got 1 here. And I'm working on this pencil. I'm doing whatever it is that I do to this pencil, okay? The other ones are just sitting there. I'm doing whatever it is that I do this pencil. I'm wrapping it in shiny glitter paper, which it is, actually. I wrap it up. And then while I'm doing that, right, that's value-added time while I'm actually making this pencil. While I'm doing that, what are the other 11 pencils in the batch doing? Absolutely nothing. They're sitting. That's a wasted time. That's wait time. They're basically sitting until it's their turn to be worked on. Okay. So now that I'm done with this one pencil, what do? I put it aside. Pencil. Sorry, dog's making weird noise. I thought he fell down the stairs. He did not. So we're good. Anyway, so I've got this one pencil, and it's done. So I put it aside. It's ready to go on to the next process. All right, and I pick up another pencil. Now I'm going to work on this one. Now what's happening here? These pencils are still waiting. That's still wasted time. And the pencil that I finished is still waiting to go to the next process. So the idea here is there's a lot of wait time in this batch. Really what there is if, let's say it takes 1 minute to do each pencil, right? So in total, that's 12 minutes, 12 pencils. But the value added piece of that, only 1 minute is value added. The other 11 minutes for this batch are non-value added because they're wait time. It's called within batch wait time. Okay, so the way you can look at that from like a formula standpoint is you can look at it as the value added time, which is 1 minute, times the batch size, which is 12 minus 1. Okay, because 11 of them, 12 minus 1 is 11, 11 of them sit around and wait while this one is being worked on. All right, so that's how we can come up with the within batch wait time, is this little formula right here. Okay, so let's look at an example. And I did mention move time or transportation time is also non-value added. Okay, so let's do an actual numbers example. I'm going to start us on the next video, and I'll be right back.